Okay. So no one has joined till now. If you wait for a few minutes, then I can start the discussion. The timing. Okay. If no one has joined till now, so just I will start. In the meantime, if anyone joins, is it visible? Hello? Am I audible?
Yes,
Okay. And the screen is visible or not? Okay. One minute. My screen is visible? Hello? Can you see this? Hello.
Yes,
Screen is visible, right?
yes.
Okay. 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 So in the last discussion, we discussed about that ionic that mean ionic coefficient, activity coefficient, these things, right? So and also we discussed some general example, but in today's class we'll discuss some uh, pure example, you can say, with some ion or salt, and then we'll discuss ionic strength and some few questions from divisional limiting law. And then we'll discuss the fugacity part that you asked last day. That fugacity part we will discuss, and a few questions from fugacity coefficient and fugacity part we will discuss. Okay, so today we'll
Okay.
discuss that. Okay, I think someone joined. Okay, so now, okay, sorry. Okay, so let me begin with the first question. Okay. So, in summary, let me just summarize first. Okay, first I'm writing the question. Question one: calculate the mean ionic activity, mean activity, just mean, not ionic, mean activity coefficient of first NaCl, and the molality is given, that is 0.01. Second, Na2SO4 at a molality 0.001. Both are in aqueous solution at 25 degrees centigrade. So we have to calculate the mean activity coefficient. Okay. So, so what is the definition of mean activity coefficient? That is also important here. Mm, the last class we discussed. Okay, that let me summarize the discussion from the last class. Okay, then we'll solve this type of question. So let us consider in general solve. Let me consider 1 minute. Yes. So just let me revise it very briefly, then we can start. Any salt, Mx, Xy, this type of salt, or Ny, you can consider Ny as well. So Mx, Ny, so it will totally dissociated M in this cation, X number of cation, and obviously Y number of anion. Okay, so this will be our dissolved ions in the solution. So now, so we discussed the total activity that is A. This is total activity. Ionic activity, how it is defined? Ionic activity that will be A plus or A minus. For anion it is A minus, for cation it is A plus. So essentially A should be A plus to the power the number of cation present, that is X, because it is A plus A plus A plus, you have to multiply. So that's why it is power, and A minus to the power Y. That is our total activity. Now, instead of X number of cation and Y number of anion, we can consider total X plus Y number of a general species of ion. So, we can consider uh, a general species of ion having the uh, mean ionic activity. So how you can calculate that mean ionic activity? That means activity of ion, average value. So that will be obviously total activity, and you have to, let's say this mean ionic activity, let's say it is A plus minus in general. So from here you can guess this is the mean ionic activity. We are considering the mean value. So purely here, from here you can write total activity should be mean ionic activity times total to the power total number of ion. So from here you can write this equation. So this is the relation. So you can, this is the first relation, you can write it. So just let me box it. Okay. Now, if you write down the activity, what is the definition of activity? Activity is eventually m times gamma. You can say this is proportional to concentration. Concentration that may be in terms of molarity, normality, any concentration that can be, but that is proportional, and there is a proportionality constant. So if it is molality, then we can write it gamma. So eventually, this all things we have discussed in the last class in detail. I am just summarizing the things. So A plus should be gamma plus and the concentration of the cation, that is M plus. Similarly, A minus should be gamma minus M minus, and A plus minus this mean value, that also can be written like this. Now just if we put it there, so from there we can write it. So what we can write from the above discussion, gamma plus minus M plus minus to the power x plus y, gamma plus M plus to the power x, gamma minus M minus to the power y. So from here we can write this. So just by comparing, we can finally write it, that what we can write, that gamma plus minus, that is also mean ionic. This is called activity coefficient. These are activity. These are all activity A. This is concentration, and this gamma are the activity coefficient. So this is similarly, this is called mean ionic activity coefficient. Mean ionic activity coefficient. So that is obviously from the above equation it is clear. It will be gamma plus to the power x, gamma minus to the power y, and 1 by x plus y. And this is the mean ionic concentration or molality. So that will be mean molality. That will be obviously similarly m plus to the power x, m minus to the power y, 1 by x plus y. Okay, so you can write it. So from here, so what we can finally write, that m plus minus x to the power y from here. So what will be m plus and m minus? That is important. So let's say if our salt was this was our salt. So if the concentration of the salt was m, this is the concentration of the salt that was in our hand. We are dissolving the salt, so we can fix the concentration in terms of molarity, normality, whatever it is. So if it is m, then after dissolving it should be xm and it should be ym. So m plus, that is essentially xm, and m minus, that is essentially ym. So just put it. So then it will be x m to the power x, y m to the power y. So it will be x to the power x, y to the power y, and then m to the power x plus y. So m plus minus will be x to the power x, y to the power y, to the power 1 xy times m. Just this is the mean molarity. So this is our mean molality, and this is the molality of salt. So when you just now after knowing this m plus minus, you can write finally a plus minus mean ionic activity coefficient will be gamma plus minus m plus minus. This was already discussed. So it will be gamma plus minus x to the power x, y to the power y, 1 by x plus y times m. And this is in called kappa. So you can write gamma plus minus kappa m. Okay, these things we have already discussed. And we have also discussed few example considering some salt. Now, in this question, what was asked? Mean activity coefficient they were asked. Mean means mean ionic activity coefficient. What is the mean ionic activity coefficient? That is this gamma plus minus. That we have to calculate. So how we can calculate that mean ionic activity coefficient? For calculating mean ionic activity coefficient, we have to use the Debye-Hückel limiting law. Okay. So that's why Debye-Hückel limiting law is important. You see here, these things we know totally. Just this gamma plus minus we don't know. We can calculate this gamma plus minus using Debye-Hückel limiting law. That limiting law will be used here. Okay. Just let me reconnect my just a second. Okay. So what was the formula for Debye-Hückel limiting law?
Log gamma plus minus equal to minus a z plus z
Minus a
minus root I.
minus. Yes. Now we have to calculate this. So log gamma plus minus. This is true for dilute solution, right? Very, very dilute solution. We can write it.
Yes.
So this is that's why it's called limiting law. So this question also asked why it is called limiting law, because this is not a general law. This is valid only for the limiting conditions.
Yes.
So what is a general law? If you don't consider this, then the actual law was this is correct. You have, but the, if you consider the total thing, okay. So this is the case. For very diluted solution, we can consider that dA is very, very less than 1. Then it will be this. So you can think that why the minus sign is not there, right?
Yes.
That's because here mod is not there. Z plus and Z minus is. So when you consider the mod, automatically minus sign will be there. Z plus is the number of cation, Z minus number of Z minus is the charge of cation, and Z minus the charge of anion. So there will be a minus sign, right? That minus sign will be there. So directly you can write.
Yes.
So That is also correct. But this is a general law. And this is called binomial A-B coefficient. This is A, this is B. This is A coefficient. And this is B coefficient. But one thing is there.
What is the significance of it?
What is the significance?
Significance of these two coefficients.
Okay, that we will discuss. In the next question, we will calculate the value of A and B, right? I'll discuss that.
Okay.
So, okay. Again, it is disconnected. That the earphone, I don't know why. Again, just to explain. But we here we will consider the for the dilute solution. But what is I? That is important here. What is I? This I. What is this I? Do you know it?
I forgot it.
Okay.
It was something half into.
Huh. But this is called ionic strength.
Yes, ionic strength.
Ionic strength. It is called I, and it is defined as half of sum over I Ci Zi square.
CIZ square, yes.
So what is Ci and what is Zi? Zi is the charge of ion.
CI is the concentration.
Yes. And Ci is the concentration of ion. So that's why it is called the ionic strength. Okay. So now here what is the solution? We have to calculate the I. Then only we can calculate the gamma. Otherwise it is straightforward. Our solution is first we have to consider for NaCl solution and the molality is given 0.01. Okay.
It is molar concentration.
Molal. Molar
The I
means
is in molar concentration.
no, it can be molal. There is no restriction.
Oh, it can be molar. Okay.
It can be molar. It can be molal. It can be molar. No problem. Here it is given as molal. Okay. So that's why we will consider the molal as well. So first is 0.01 molal NaCl. So how NaCl dissolve? NaCl dissolves like
Na plus Cl minus
Na plus Cl minus. Correct. Na plus Cl minus. So Z plus is Z plus
plus 1.
1 plus 1. Z minus is minus 1. So what will be I? So I will be half of Ci square. Can write it like this. Just plus. So what is C plus and C minus? That we'll calculate. But for time being, we can write it as C plus 1 square is 1 and C minus. This is also 1. Okay. So now NaCl. So let's say if the concentration of NaCl is X, as then it will dissolve, then X number of Na plus ion will be generated and X number of Cl minus ion will be generated. Okay.
Yes.
And what is the concentration here? 0.01 molar.
0.01 molar.
What is the difference between molar and molar? What difference between molar and molar?
Thus,
Just let me
molar
explain
is
you.
in 1000 ml the number of moles, and it is in 1000 gram number of moles.
1000, just okay, yes. So if let's say it is X molar, means X mole of solute is dissolved in, correct, 1000 ml of solution, right? This is X molar. And when we are saying X molal, that means X mole of solute is dissolved in 1000 gram of solvent. This is important. It is solution, it is solvent. Okay, X mole, X mole. But this is 1000 ml, 1000 gram. Is it clear? This is a definition of molar and molar.
I have to change anything or it does not need
No,
for
here
given
it is not
questions.
needed. No, here it is not needed, because if you look at everything, this gamma plus minus will be then in terms of molar. If you consider it molar, then it will be in molar. Later you can change from molar to molar. Just for changing that, you need the density, because you have to change this ml to gram.
Yes.
That's it. Otherwise, it's easy. Here we will consider the molar, no problem. So what is the X? X is 0.01. So C plus will be also 0.01 and C minus will also be the 0.01. So if you put it, then it will be 0.01. Okay, is it clear? Just check it. This I is clear.
Yes.
Okay. Now after knowing I, it is very straightforward. Nothing is there. So what will be our uh, log gamma plus minus? That will be minus a z plus z minus root over I. What is a? What is the value of a?
0.509.
Yes, you have to remind that. But this is for at a particular temperature. Okay, that is also given
Which
here.
temperature?
25 degrees centigrade. Then only you can use. That is also given in the question. 25 degrees centigrade and for aqua solution. Okay.
Okay.
Otherwise you can't use. Yeah. This is the value for 25 degree. And z plus z minus. So z plus is plus 1. Z minus is minus 1. It will be minus 1. So again it will be 1. And it will be root over 0.01. So what will be the answer? 0.509 into root over 0.01. Oh, 1 minute. Just let me turn on the math solver. Yes. 0.509 into 0.01. So it is minus 0.051. Okay. So this is the log. But we need to calculate gamma plus minus. So it will be 10 to the power minus 0.051. No, it should not be 1. It is close to 1. But what is the appropriate value? It will be 0.08, no, 0.889. Just check it whether I am correct or not. This is the gamma plus minus.
0.8892.
0.8892, correct. So this is gamma plus minus. This was asked, but from here also you can calculate the mean ionic activity. It is mean ionic activity coefficient. This is mean
Yes.
ionic activity coefficient. So what will be the mean ionic activity? That we have already discussed. That is A plus minus. It will be gamma plus minus into M plus minus. And what is M plus minus? M plus minus is x to the power x, y to the power y, 1 by x plus y times M. Okay, x and y. What is x and y? Both are 1. If you remember, this is for NaCl. This is x, this is y, coefficient. So, this is also 1. This is also 1. So, x and y both are 1. So, it will be 1 to the power 1, 1 to the power 1, and 1 by 2. And M was 0.01 molar, if you remember. So, it will be 0.8892. It will be 1 and it will be 0.01. So, what will be the answer? No, this is not as good as calculator. Okay. So what will be the answer?
8.89 10 to the power minus 3.
Okay. 8.8. Yes, that should be. This is just one. So this is the mean ionic activity coefficient. And what will be the unit? That is important. Unit is important. What is the unit for this gamma plus minus?
Gamma plus minus should not have any unit because
Why?
it is in log. It is under log.
Yes. So this value, this I has unit. This has unit. Because the definition
Yes.
of I was Ci Zi square. Zi is the charge, but Ci was in the molal. So the unit should be molal. For I, the unit is molal. But this value of A, this has also the unit. That I will discuss in the next question. So that unit will be cancel each other. And after that, this log gamma plus minus is a number. So that's why gamma plus minus is also a number. So eventually, this unit of the concentration that will guide. Here it is molal. So obviously, it will be the molal. Okay, this is the activity. So just see the activity is this, but the concentration is 10 to the power minus 2 molar. But activity is this. So you can see the activity and concentration is not the same. Mean any activity is different. Okay.
Yes.
Na2SO4 and molarity is 0.001. So 0.001 molar Na2SO4. So how first we have to just write how Na2SO4 will dissolve. It will dissolve as 2Na plus SO4 2 minus. So this is X, that is 2, and Y is 1. Okay. So if the concentration is C, first it will be 0, 0. After dissolving, it is 0 and it is 2C and it is C. So you can write C plus eventually 2C and C minus eventually C. Is it clear?
Yes.
Yes. Okay. It's straightforward. Just now we have to calculate. Nothing is there. I. First I will calculate. I will be half of Ci z square sum over. So C plus Z plus square plus C minus Z minus square. So put it. Okay, Z plus and Z minus. What is the Z plus and Z minus? Z plus is plus 1, but z
2,
minus is
sorry,
minus 2. Hmm. So it is 2c plus 1 square,
and
c
it's C minus 2
minus
square.
2 square, correct. So it will be half of 2c plus 4c. So it is 3c. Okay, and c is 0.001. We will put it later, but continue as c. So log gamma plus minus will be minus 0.509, z plus z minus, so it will be 2 and root over I, that is 0.003. Okay, so it will be, if you calculate, it will be 0.0558, and the gamma plus minus will be 10 to the power, obviously minus 0.0558, and it will be 0.8795, and a plus minus will be this. So 0.8795 into x to the power x means 1 to the power, sorry, 2 to the power 2, 2 to the power 2, 1 to the power 1 divided by 1 3 times m, and m is 0.001. Just check the values are correct or not. This is 4 to the power, so 0.001. What is the value? Just bring the calculator.
1.38 into 10 to the power minus 3.
Let me also calculate 1.3 9, I hope.
1.38,
Okay,
yes,
38,
39
39
into
minus 3. So you see here the mean ionic activity coefficient, okay, is greater, basically is greater than the molarity. It is 0.01. This is, but this is greater than this. Why? Because it is 4 to the power 1 by 3. Okay, that's why 4 to the power 1 by 3 is eventually uh, that is greater than 1. That is the reason here, and that should be
1.58.
1.58. That is the reason. Okay, now we will discuss the next
Can
question.
it be greater than the activity coefficient?
Activity coefficient.
Sorry, activity, concentration.
Yes, that is happening. This concentration is concentration of the salt. Why it is happening? Because you see, this salt, Na2SO4, one molecule of this Na2SO4 salt is giving 3 ions, basically. That's why. That is the reason.
Yes,
That is the reason why this value is large. Okay. But
yes,
in case of NaCl, it was 1 to the power 1 and 1 to the power 1. That's why that factor was not arising, because this was become 1. This kappa is very important. This is the kappa, right? This is the kappa.
yes,
This kappa is here 1.58 something you obtain. But before, in case of this NaCl problem, this kappa was 1. So that's why that was not impactful in that case. But here that actually dominates. And it's become the greater than 1, the molality. This is this molar. This is the mean ionic activity coefficient. Okay. Okay. Now Okay, now we'll discuss the question number 2. Okay, now in this question we'll discuss few example of ionic strength. We have to calculate the ionic strength. Calculate the ionic strength of first 0.15 molar KCl solution. Zero point 0.25 molar K2SO4 solution. 0.2 molar BaCl2 solution. Last one is a solution is 0.1 molar in KCl and 0.2 molar in not in of molar of K2SO4. Everything is in molar, so no problem. Just you have to calculate it. I think it is easy. Just you calculate it, then I will also do. Okay. Okay. So should I start?
Yes, I am also calculating.
Oh, oh. This is the first problem, right? Just first, what is the procedure? First, you have to write down the reaction. Okay. A starting
That's
concentration.
the gamma plus minus calculation.
No, gamma plus minus I don't need here. I have to just calculate the ionic strength. Okay, just ionic
Okay, I
strength.
understand.
Gamma plus minus it's not needed here. So after dissolving, it is 0, C, C.
0 cc.
So C plus is C, C minus is C, Z plus is 1. It is very, very trivial. So you can write I is equals to why it is 0.5. It should be 0.5. No, I don't think. Let us calculate.
Half into then 0.
It is half CI0 square C plus Z plus square. So it will be half C plus is C. Z plus this will be 1 and 1. So it is just C. So it will be 0.15
0.15.
molar.
Yes.
This is the I. So you can you can also remind as a trick for a salt which has the monovalent cation, monovalent anion like this K plus Cl minus. It will be just direct C ionic strength. You don't need to calculate. Okay, you can remind it. Eventually, it will be reminded automatically. After doing few example, it will be
For
reminded.
monovalent.
Just see here K plus Cl minus.
For NaCl it will also be same.
Same. Next one is K2SO4. Okay, so K2SO4.
2K plus SO4 2 minus.
Yes, this is just like that Na2SO4. So first it is C00, 0 to C. So C plus is eventually 2C and C minus is eventually C. Z plus is 1, but Z
Z
minus
minus
is
is 2.
2. So it will be 3C. If you remember, it will be 3. So half C plus Z plus square plus C minus Z minus square. So it is 2C plus 3 into 4. So 3C. And the in question it was 0.25, so it is 0.75 molal. Okay.
Yes.
Now can you guess the next one? 0.2 molal of BaCl2.
It will be same 3C
Why?
because it is producing same number of ions.
Set number of ions. Yes, that's correct. Let us check. Your logic is correct, but let us check. So it is C to C to C. So C plus is C, C minus is 2C, Z
Z
plus
plus is 2, Z minus is 1.
Z minus is 1. So eventually I will be okay. So C 4C plus 2C. Yes, it's 3C. And the concentration that was asked in the question was 0.2 molar. So it will be 0.6 molar. And the last one, it is quite non-trivial, I think. They have asked a solution which are two types of ion salts, KCl and K2SO4.
How to do this?
You have to take the sum,
The
calculate
ions
it
will interact
separately.
itself.
No. In that case, we should not consider that. And how it will interact? K plus, Cl minus, SO4 2 minus. These three types of ion will be there. Interaction from
Yes.
anything. No interaction. Just calculate it and then I'll do.
For the first portion, it is 0.1.
Okay, because it is direct KCl monovalent. And the second one, that is also no. It is three
3
times
into 0.2, 0.6.
0.6 and total will be 0.7.
0.7.
Okay. Now you see, you can do it just by in your thought. You can do it. You don't need to solve in written.
Yes.
So I'm not doing it. It's very easy. I'm just writing here. Do it if anybody want to do. Okay. Okay. So now in this question, that AB coefficient we have to discuss. That is an important part. Yes. Okay. Question number 3. I think this is not the pure K. Now find out value of coefficient A and coefficient B in the Debye limiting law.
One is 0.509 and another I don't know.
No, 0.509, that is correct, but that is for water and at 25 degrees centigrade. That you have to mention. Okay. So do you remember the expression? That is not possible. So what was our Debye limiting law? Z plus
Minus z plus z minus
A root over I 1
by
plus
1 plus dA
what is A?
to
A is
root I.
activity. Okay.
Yes,
So here what is needed? The form of A and B. A. A is E square divided by 2.303 into 2 kBT into 4 pi epsilon. This part into 2 square Na divided by epsilon kBT to the power half. So this is the expression of A.
how to get this?
How to get this? If you solve the
Yes,
Debye limiting law, then it will appear. Do you have studied that proof of Debye limiting law?
no.
Okay. Uh, for these parts, you are asking for a book. Okay, then note. Oh, I forgot to upload. I find out. Okay, that PDF I will upload, and for thermodynamics, classical thermodynamics, that PDF I will upload today. Okay, I forgot that. But for
Okay,
for this this solution part, there is a book. I forgot the name, but I have the PDF probably. Ion interaction part is very well discussed there. This Debye limiting law, this. So from there you can read it if you wish. This is
what
not
is the
very
other name?
that I forgot. I have to remind. This is actually that is called Bible for this ion solvent interaction. Okay, the solution part, that is Bible for the solution chemistry. I
Please
forgot the name.
upload it.
I'll share you the name. You can download it from LibGen or any PDF that is available. PDF I don't
Okay,
have. I think book I have to find out. Okay, because these things this was this part Debye limiting law. This part was actually taught from that book in my masters in first year. But that book was very good. It's very step by step they have discussed this total derivation Debye limiting law, this part. But this is the expression, okay,
okay.
and this is the B. Basically, this is B, and this is A prime. So A equals to A prime B. Okay. Now first we will calculate the B. What is the B? Then if after calculating B, we can I think easily calculate the yes. That we'll have to put B and A prime, and after multiplying we can easily calculate. Okay. B is 2 square Na divided by epsilon kbt. 1 minute. Yes, I think it's right. So what is the value of epsilon for water? Hmm. For water,
What is the epsilon?
epsilon is the dielectric constant. If you
I don't
remember,
know it.
oh, you okay, okay. Just think like that. You know the Coulomb's law.
Yes.
What is the attraction force between these?
1 by 4 pi epsilon Q1 Q2 by R square.
What is this? Same thing. This is
That
for
is for physics.
no, that is for physics, but that is for this medium, any medium, if you consider. But if it is liquid, then it is called dielectric constant. Here it is called permeability, I think. So different name, but the significance is the same. Okay, 4 pi epsilon. If it is vacuum, then it is 4 pi epsilon naught. Okay, but
Yes.
if it is not vacuum, then it is 4 pi epsilon. And this epsilon is actually epsilon naught into epsilon r. Epsilon r is the relative, that is epsilon by epsilon naught. In this way, it is discussed. But for water, it is
Why we should use the water?
because we are considering the dilute solution of water. Because this de Broglie limiting law is valid for ion, which is dissolved in a solution. We are considering solution is the aqueous solution. So not for water, it's for aqueous solution. Okay. This is dielectric constant for the aqueous solution. Epsilon. Is it clear?
Yes.
You can read it from that physics book when this is Coulomb law is discussed. There it is discussed. This epsilon. It's not very difficult. It's easy. 8, 5, 4, 10 to the power minus 12 Coulomb square, second square, 2 meter per second.
8.854, I think it's for free space.
Yes, and this 78 is for it's liquid. That's why epsilon r. That is.
It is a
I
relative.
I write down this. That is for free space, and epsilon r will change. So for water, epsilon r is 78. Okay.
7.08 into 10 to the power minus 10.
What? If you multiply it, okay, that we'll do later because there are other factors as well. Okay. So it is 2 into e square. E is what is the E? Is the charge of E is not the exponential. Is the charge of
2.7. Oh, sorry.
is the charge of electron because you are talking about the
1.6
ions, right?
into.
1.6 into 10
Yes.
to the power minus 19 coulomb
19.
square. Na is 6.022 10 to the power minus 23 mole
10 to the
inverse.
power 23. Mole in. Sorry.
Mm. Okay. Next is epsilon, that is 78 8.854 10 to the power minus 12 coulomb square. That's kb. Kb is 6
1.38 into 10 to the
10
power
to the power
minus 23.
minus 23. What will be the unit of kb? Joule per Kelvin, and it is at 298 K.
298 Kelvin.
Okay, so unit you have to just calculate it. Right? Unit, say Coulomb square will not be there. Uh, okay, let us do first. What is the value? Then we'll do the unit. 2 into 1.6 into 1.6 into 6.022 divided by 78 into 8.54 into 1.38 into 298. This value is showing. They don't. You also check whether it is correct or not. 7.82 into 10 to the power 1, 2, 3, 4, 5, 6, 6. And the power part, it is 23 will be cancelled out. 23 will be cancelled out. Here it is 20. It is only 12.
But it will be 10 to the power 46.
Why?
After going upward, it will be plus 23.
You are correct. So 10 to the power minus 38, just do it explicitly. Plus 23, plus 23, plus 12. Now it is correct, I think. So it is 10 to the power 22.
Yes.
Or I'm doing something wrong. Just check it. No, there is a wrong thing. No. Okay, okay. It's to the power half. Overall was to the power half. That I have to put. Very good. So it will be 90. 30. Just check the calculation. I don't know. If it is wrong, then everything will be
2.79.
2.79. From where to is
After doing the
after
root.
taking no 2.79 will not be there. Then it is something wrong. Because the final answer is known to me. But not known to me, it is written in the book. I'm also calculating.
I am not getting the same answer for the numerical part,
Mm.
excluding the 10 to the power part.
Mm. So it is 1.08
Yes, 1.08.
into 10 to the power minus 8.
I am getting this.
Minus 8 also you are getting, right?
Yes, but without doing the root.
Hmm. But why minus? Minus should not be.
Minus,
Why
not,
minus is
I
appear
think.
to me?
It's 10 to the power 20.
Then I miss something again. Shift on units. Again, I will do it 2 into 1.6 into 10 to the power minus 19 whole square into 6.022 into 10 to the power 23 divided by 78 into 8.854 into 10 to the power minus 12 into 1.38 into 10 to the power minus 23
10 to the power 16.
16. Yes, 16. So the final answer is 1.0419 into 10 to the power 8. But what will be the unit? That part is still remaining.
1.0416.
Here it is 29. Okay, that's not matter. Okay, but unit is important. So explicitly we can see the mole inverse will be there, cancel out. Coulomb square will not be there. Kelvin will not be there. So joule is there.
Joule inverse.
Joule, kilogram inverse, second square. Hmm. Oh, it's not mole. Sorry. It's meter. Now calculate. So joule, what is joule? Newton meter. Newton is kilogram meter per second square. So this is joule, right?
Yes.
And we have also kilogram inverse at second square. Okay, so it will cancel out, cancel out, cancel out. So meter to the power minus 1, mole to the power minus 1 to the power half. Okay, so this is the unit.
Okay.
So this is the unit. Yes. So this is the value of B. Now we know the value of B. And after knowing the value of B, we can calculate the value of A. For that, we need to calculate this A prime. A prime is okay. So just put it the values 4 pi epsilon. This unit will be okay. Unit will calculate later. Just calculate it. And for the unit part, Coulomb square will be there, and kBt. kBt is actually the joule. Joule and epsilon has Coulomb square second square kilogram inverse, meter to the minus 3, and joule was, we have already calculated joule. Joule is kilogram meter per second square meter this. So everything becomes in hmm. So it's just uh, meter inverse. Meter inverse, but upstairs it will be meter. Meter, yes. Just calculate the numerical value. It is showing written 1 point. Just check whether is it matching or not. This is okay. What are you getting?
1 minute.
Mhm.
- 9.73.
You are getting 9.73.
Yes.
Oh, so sad. I don't know where is the mistake. Let me do it then.
4 into pi into 78 into 8.854. The last line.
Hmm.
So I'm getting this.
Let me calculate. Numerator is 1.6 into 10 to the power. Okay. Here is square.
Okay. I am getting the same.
Same, right? Okay.
Yes.
So A will be this. So just write it. It is 1.557 into 10 to the power minus 10 meter. And here it is 1.0419 into 10 to the power minus, not minus, it is probably plus. Yes, 8 meter to the power minus half, mole to the power minus half. So what is the answer?
1.62 into 10 to the power minus 2.
1 point? 1 point.
62 into 10 to the power minus 2.
1 point should not be there. 1 minute. Then something is wrong. Correct. 1.62, right?
Yes.
Hmm. Into 10 to the power minus 2 meter to the power half mole to the power minus half. Hmm. So is it matching?
Yes.
But what
Sorry, no. It is
no.
0.509.
So where is the mistake?
Calculation mistake.
No, not calculation mistake. You have to convert it from meter to the power this to decimeter. Okay. That conversion we have to do. it is, let us do, okay, it was m to the power half, sorry, so it was m to the power 3 by 2. Yes, now we have to change it. 1 meter is
10 decimeter.
10 decimeter. So 1 will be 10 to the power 3 by 2 decimeter to the power 3 by 2. Correct?
Yes,
So 10 to the power 3 by 2.
I
Calculate.
have converted, but I am getting 0.512 instead of 0.509.
Okay, that is understandable. 0.512.
12.
That's all. That's all. 509 is the experimental value.
Why this is the error?
Okay. 509 is the experimental value.
Okay, and it is theoretical.
You calculate it. Totally theoretical, everything. So it's matching. It's a good agreement. 509 and 512 is very, very good agreement if you think like that.
Yes.
Okay. So this is the A and B coefficient. And this is, let me write it. Theoretical value. And the actual value is 0.509.
Why it is taken in decimeter unit?
So that it can be easily decimeter. Okay, just think it is easy. 1 decimeter cube means 1 liter means
Yes.
1000 ml means,
Okay.
and so when 3 by 2, so it will be just 10 to the power half, right?
Yes.
So that's why that conversion is easier because decimeter cube is related to liter, na, directly, not meter cube.
Yes.
That is the reason. And you know all the molarity, everything is in liter.
Yes.
So that is why it's easy to calculate later on.
For molality, why it is not showing any defection?
No, when you calculated it, let's say, okay, just multiply it. For take any example that, let's say, this ionic strength is molal. When you this, if you consider this, so what are you doing here specifically? This is root over I. So root over I means molal means mole
In
per
1000 gram, there is 1 mole.
1000 gram in so mole per kg. You can think like
Yes.
that, and you are taking a half after getting root, and this unit is we already calculated. This is decimeter to the power 3 by 2 into mole to the power minus half. So it gone. Okay. So it is
Yes.
decimeter to the power 3 by 2 and kg to the power minus half. Now what is the density of water?
1.
1. So that's it.
1
Okay.
kg per meter cube.
1 kg per meter cube. So 1 kg, the rho is 1 kg per meter cube. So you can write it. That means if the weight is 1 kg, that means it is actually 1 meter cube, right?
Yes.
So if it is 1 meter cube, that means it is, and one meter is 10 decimeter. So it is 10 to the power 3 decimeter cube. Or I'm doing some wrong. Just do it explicitly. If you do it, let me do it. So okay. So density is kg per meter cube. That means this is m by v. M by v, we need volume. So let's say if there is 1 kg, so 1 kg will have the volume 1 meter cube. Correct? Yes.
Yes.
Yes. So we have 1 kg, 1 meter cube, and 1 meter cube is 1 meter is 10 to the power, or this is 10 to the power 3 decimeter cube. Okay. So
Yes.
but it is kg. Okay. Kg to the power half. Kg to the power half is there. Just let me think. It is molal. Yes, when it is molal, it is mol per liter. Mol per liter, if I put, okay, let's say mol per liter, then mol by it is liter to the power half. 3 by 2 and liter to the power half, that should have unit less. What does it have? Ci Zi square. Hmm. No, it's correct. It's correct. It's liter to the power half. You get it? Let's say it was kg to the power minus half, right?
Yes.
Hmm. So if it is kg to the power minus half, so 1 kg is 1 meter cube, right?
Yes.
And 1 meter cube means 1 liter. It's actually, I
Yes.
think you are saying wrong. It's 1 decimeter cube.
One,
Check it. 1 kg per 1 decimeter cube, not meter cube. Density of water.
1 gram per cc.
1 gram per cc. Yes. So 1 gram per cc. Cc means ml
Centimeter cube.
or centimeter cube. That means if you take 1 gram, it will be 1 centimeter cube. So if it is 1 kg, that means it's 10 to the power 3 centimeter cube. Means 10
1 decimeter
means
cube.
1 decimeter cube. And it is kg to the power minus
1
half.
liter.
So it is 1 kg to the power minus half means 1 decimeter to the power 3 by 2 minus 3 by 2. So it is, you can write it kg to the power minus half is decimeter to the power minus 3 by 2, and it is gone. Okay.
Okay.
So that's it. That's all. Okay. That's why for water, molality and molarity is very easy to convert. The density is one, no? That's the reason. Okay. 1 minute. Hold on call is to me. হ্যাঁ বল।
বলছি একটা এক্সপ্রেস আছে দেখছি বাড়ির থেকে থাকছে 18034 থাকছিল এক্সপ্রেস হাওড়া পর্যন্ত
ওয়ান
এখানে চলে এসছি। হ্যাঁ,
ওয়ান ই
18034
18034 তুই কি ইউটিএস এ বলছিস?
হাওড়া হাওড়া মেমু মেমু তো খড়গপুর থেকে হাওড়া পর্যন্ত।
ইউটিএস বলছিস তো?
তো ওখানে
হ্যাঁ, কেন কাটা যাবে না? এক্সপ্রেস কেটেছিলাম তো দেখো।
কাট 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 কাট
বেশ।
আমি পজিশনটা বলি কোথায় আছে।
বগি পজিশন কোথা থেকে ও ট্রেনটার বলছিস?
হ্যাঁ হ্যাঁ হ্যাঁ,
বেশ।
তুই জানিস হবে না।
বেশ, আমি বলছি, ঠিক আছে, আমি বলছি, এক্ষুনি বলতে হবে, আমার ক্লাস চলছিল আসলে। NPTEL। হ্যাঁ, আমি পজ করে ধরলাম। বেশ, আমি কেটে পাঠিয়ে দিচ্ছি। বেশ, বেশ। ওকে। Okay, so now we'll Next question. We'll move to the next question. It was question number 3. Is it clear right now? No, there is no doubt.
Yes.
Hope so. Yes. So now I will discuss few more questions from this Divahical limiting law. Then we'll, if the time permits, then we'll discuss fugacity. Otherwise, in next class we'll discuss. So it's question number 4. The screen has been disconnected, right? 1 minute. Let me connect it. What's wrong? Hmm. So is it visible?
Yes.
Let me find a question. Just wait for a minute. Hmm. Okay. Sorry. I had to go quick to keep that side. Okay. So now Divahical limit length. So do you know this Divahical length?
Divihucal?
Length. Screening length.
No.
Okay. So should I discuss or not?
What is it?
Okay. What is the when there is a, let's say, any ion, any positively charged ion, let's say there is a solution and you are considering you are not considering focusing on a cation or an ion, anything. Here we are, I'm considering a cation. So then up to a certain limit, what happens? It has a solvation sheet because around this cation there are many anions are there, right?
Yes.
And these anions concentration, if you plot the concentration of these anions, if I plot with the from R versus R, this concentration of anion and R, then it will varies like this. Okay. Mm, this kind of plot do you seen before?
What?
This kind of plot, this kind of distribution, do you have seen before?
Yes. Velocity distribution of gas.
Velocity distribution of gas, or you can hydrogen atom. Do you have studied hydrogen atom?
Yes. Little bit.
Yes. So what happens here actually, how this plot appears? Just understand the concentration. What should be the concentration density? If you understand the density, density will decrease as long R will increase like this exponentially. It should be.
Yes.
And the area, the volume of the cell, that will be increased like this,
Yes.
4 pi r square, that is. And if you combine these two,
Yes.
because that will be the total combination, that will be this.
Okay.
From here, and this length, where it is maximum, this is called the Debye screening length. Okay.
Okay.
So that length we can calculate.
How?
For there is a formula. If you want, I can discuss that.
Okay.
So okay, then I can.
What is the significance of this length?
That actually signifies that after that length, another solvation sheet is creating. That I'm not going into details, but we can calculate it. That is just a numerical exercise. Mm, okay, let me discuss it. So first I'm to write the question. Oh, sorry. Mm, Solutions of three electrolytes. Okay, 1 minute, please pause it. Again, one call is coming. Just I have to take one. My dad is calling me to. Oh, okay, sorry. Oh, so much disturbance. So, solution of three electrolytes have the same ionic strength and different dielectric constant as 4, 25, and 81. Okay. Expected temperature is 225 Kelvin, 256 Kelvin, and 298 Kelvin. The corresponding relative magnitude of the bifocal screening length of the three solutions are. So you have three different solution of different three electrolytes have the same ionic strength. Ionic strength are the same for all these three solutions, so electrolyte, but different dielectric constant. Dielectric constant means is epsilon. That is given 4, 25 and 81. For water it was 78 if you remember. Okay.
Yes.
Expected the temperature is given for three solutions. So the corresponding relative magnitude of dibivocal screening lengths of these three solutions are, we have to calculate it. This is purely formula based question. This type of question also being asked in the question. If you know the formula, you can do it. Otherwise, so what is the formula? Let me write. So dibivocal screening length, that is denoted by kappa inverse. Okay,
Okay.
or RD. R for the length radius and D is for the dibi. Why it is called kappa inverse? Because when you do the calculation, divide the total derivation, then it is appears as 1 by kappa. RD. Okay, RD appears as 1 by kappa. That's why. And the kappa is 2 square NAI divided by epsilon kBT. Just see that this form already you have seen in the form of A and B, right?
Yes.
So from there it is actually coming. But this is the case. This is the kappa. So what will be the RD? That is the kappa inverse. That will be 2 square NAI divided by epsilon kBT to the power minus half. Or you can write epsilon kBT divided by 2 square NAI to the power half. So see here, kBT, NAE, these are the constant. So it is R depends on, RD actually depends on epsilon T by I. Okay. So how you can visualize it? Just for, let me draw it. Then you can visualize it easily. Here, let's say a cation is there. So around this cation, there is a
It is a sheet-like structure.
sheet-like structure. And this is, let's say, R. And that distribution I discussed, that is like
Yes.
this. I can discuss dibivocal, but it will take a total whole class. It is a very long derivation. So this R, the concentration varies. Just I said like this, and this is the RD or kappa inverse. Okay. Now from here, now you can do it. I is same for three solution, RD1, RD2, RD3. For all three solution, R is same. So you can write it for our case. For this problem, what you can write, that RD is eventually proportional to ET to the power half. Correct? Because I is same. Okay? Is it clear?
It is proportional to.
Hmm. Is proportional to ET to the
It
power
is not
half.
equal.
No, there is T, there is E square, KB, these things are there.
Yes.
Just see whether it is understandable or not. From here, you can write it. Is it clear?
Yes.
So, but it is general case. But in our case, for all three solutions, our ionic strength is same. That is mentioned here. Same ionic strength.
Yes.
So if the ionic strength is same, then I will not be important here. I will be same. So we can write RD proportional to root over epsilon P. Okay.
Okay, it's RD. I was thinking it was R0.
Oh no no RD, not RG. So you can write it epsilon. You know epsilon is epsilon R into epsilon 0 into T. Okay. Okay.
Okay.
And epsilon 0 is constant, so you can easily
Yes.
write it as this. So, so RD1 is to RD2. There are three types of solution. Is to RD3 will be root over of epsilon R1 P1 is to root over epsilon R2 P2 is to root over epsilon R3 T3. And these data are given to us. What is epsilon R1? R1 is 4 and P1 is 2 to 5. So it is root over 4 into 2 to 5 is do. It is 25 into 256. And last one is 81 into 298. Okay.
Okay.
So just do it. What will be the
30,
answer? 30,
80.
80, 155.36.
Okay.
So this is the ratio. Okay. So let us
The
discuss
last
one.
one has the largest set.
Hmm. Why? Just see that dielectric constant is 81.
Yes.
This is the primary solvation sheet. There are then secondary other solvation sheets are there also.
After primary, it's secondary.
Obviously, but this is the maximum value. Maximum value. This is Mm, for actual plot. How
Okay.
it look like? You can think like that. 2:2p. You have seen na? That type of behavior will appear here.
Yes.
Detailing I don't remember right now as well, but this RD I remember. This is just kappa inverse. So, but this derivation is quite lengthy. But it is good. It's easy, not easy, but it's enjoyable. This overall derivation. Okay, it was
Yes.
5 or 6. 5. So let us discuss one more question from this numerical limiting law. Then this part will be completed. Fugacity is not possible today. Then we will discuss in the next class. But fugacity I will do. Sorry. Fugacity and the thermoelectric. Not sorry that uh, thermochemistry. That thermochemistry also I thought to discuss in class till now thermochemistry has not been discussed, right? But thermochemistry is
Yes.
important. From thermochemistry, very easy question they ask, very
Yes.
easy. But it is so probably in next class I will discuss the thermochemistry and this fluidity part. Then it will be, I think, hmm, completed. And in this week, that KPK, this equilibrium constant, this thing discussed. I think this thing you have already studied in class 11, 12. But here it is just from
Yes.
thermodynamic viewpoint. In general, what we have studied in 11, 12, that first we have studied this equilibrium constant, then we have related to that K, quotient, and thermodynamics equilibrium constant, like with that gives free energy. But
Yes.
here, from the gives free energy, we have, ma'am has taught. That is also good. That is also good. Okay, so dielectric constant of salt AB and A2B is 100 and 1 to 1. If the concentration of AB is 0.01 molar and that of A2B is 0.02 molar, then the relation between the RD at the same temperature. There are options as well, few options. This is first. And the fourth one is can't be predicted. So you can try. You know the expression, right? This is the expression.
Yes.
This is the expression. Is proportional to Et by I to the power half. That is, you don't need to remember, just see explicitly they don't want to calculate this explicit value. That is not very straightforward, because for that case you have to remind the total expression. That is not very easy. But you can remind this Rd is proportional to Et by I, root over Et by I. From that you can do it also.
AB is greater than A2B
Hmm. Yes. So
and the
for it,
RD is greater for A2B.
no, RD is the same. RD and K
Sorry,
is
sorry.
also same. RD is
K
the
K
kappa
is
inverse.
greater than.
K is not important. Direct, you have to remind this RD. RD is kappa inverse. Et by I. So we know that RD, that is the kappa inverse, that is proportional to root over Et by I. But here it is the same
Yes.
temperature. So we can write it for our case. In this case, it is root over E by I, epsilon by I. And you know this epsilon can be written as epsilon 0 into epsilon r by I, and epsilon 0 is a constant term. So directly you can write it epsilon r by I. Okay. Is it clear?
Yes.
Now the epsilon r is given 100 and 121, but we have to calculate just this I. So IAB first. What will be the IAB? It is a monovalent thing, so it will be just directly
Half.
0.01.
Yes, directly 0.01.
Correct, because it is monovalent. For monovalent case, we will not do anything. But A to B, you can calculate. But you know, it will be three
Two thirds.
times. It should be the three times. Three times
Yes.
of the concentration. So I A to B will be 3 into the concentration, that is 0.02. Should I do it or it is understandable?
Yes, it's understandable.
Oh, so this is I to B, A to B. So RD of AB, that will be proportional to, okay, directly we can write it. If you RD A to B, so it will be root over of epsilon R of AB divided by I of AB into I of A to B divided by epsilon R of A to B. What is the value? Epsilon RAB 100 and is 121. So it is 100 divided by 121, and I A to B is 0.06 and it is 0.01. So it is 10 into root 6 by 11. Okay. So eventually it is greater than 1.
Yes.
So RD of AB should be greater than RD of A to B. And RD means the kappa inverse.
Kappa inverse.
Okay. So this is the correct option. So this is the correct option, option C. Okay. So probably there is no other question. Let me also check. Because I thought to discuss that fugacity part. The fugacity part at least will take 30 minutes. Okay, so
Okay.
it's not to discuss today. Mm, let me check whether any
Is
other
it
question.
important for jam?
Fugacity? Sometimes.
Yes.
Fugacity sometimes they ask. Very trivial question they ask. Because it's not difficult. It's easy. If you know the Van der Waals equations, just you have to plug the instead of pressure, there will be fugacity. It's easy. It's easy. That's why I'll not discuss very in detail. Um, Maximum 30 to 45 minutes. Under 45 minutes, it will be covered.
Okay.
Two, three questions from that fugacity part we will discuss, and it will be enough.
And from the equilibrium part, how difficult question is asked?
No, equilibrium part questions are very easy from 11, 12 level.
By applying the
Correct.
chemical potential.
From Gibbs Duhem equation, and after that, the common questions are entropy of mixing, entropy of Gibbs free energy, mixing of Gibbs free energy. These questions are very oftenly asked in jam, in gate also. This ionic coefficient, this ionic strength, mean ionic values, these questions they ask. These are very easy questions, but they ask this I or gamma plus minus, or the A plus minus, this average value, mean ionic activity coefficient. These questions are asked.
Okay.
In NAT also they ask. In my time, they asked something. If I remember properly, it was MX4 type of salt. If I'm not wrong, that is M4 plus and 4X minus something. So if the concentration, that will be C, and it will be 4C. So C plus is C, and C minus is 4C. Okay. And X is 1, Y is 4. So kappa will be 1 to the power 1, 4 to the power 4, and 1 by 5 something. Then here is molar. So that this was gamma plus minus into 4 to the power 4 by 5 molar, something like that. If I remember. And molarity was given directly, question, direct formula based question was there. Not numerical question, but this type of MX4, like this type of salt that was given. So this type of question they asked. Okay, for today I'm not finding any more questions here. It is because the other question I sorted out, that questions are from that fugacity part. 2, 3 questions are there. Okay, so in next class I will discuss that fugacity part, and the thermochemistry. Thermochemistry part is also important. Then I think, I don't know, in upcoming week what's the lecture, what the content of the lecture. Do you have seen anything?
Okay, let me a minute.
Hmm. According to that, I will prepare. Next week it's clear to me what I have to discuss. After that, I have to see, think. I have to think.
For the next week.
For the next week, I will discuss this fugacity part and this thermochemistry part. And then I thought to discuss some miscellaneous type of question, because probably it's more or less completed, the thermodynamics. No
This
other
week
top
equilibrium is discussed, and next week is numerical problems
numericals problem eventually, yes. I will also discuss the numerical problems.
and electrochemistry also.
Electrochemistry, okay, I can discuss. Electrochemistry I can discuss, but electrochemistry is another topic. It's a vast topic, like thermodynamics, right? So, as a part of thermodynamics, electrochemistry is not very um, it, convenient to discuss. Okay, but I'll see. I have to sort out various type of question from various domain, and then I will discuss for
After
last.
that, it in the last week it's thermodynamic stability and thermodynamics in action.
Okay, okay, that's okay. But I have to take a special class, because I thought to discuss the Joule Thomson coefficient, that part, and that Gibbs-Helmholtz equation. That two part was there remaining after completing this, because at last they asked for an extra lecture. Last time I did not take, but this time I'm thinking to take. Then in that extra lecture, I will discuss that. Okay.
Okay.
Okay. So let me stop presenting. Stop presenting. Okay. Okay, so in between, if you have any other doubt, then you can ask, or if you start in any numerical problem, that also you can send to me. I will discuss that in the next class as well. I'll see the assignment they have uploaded in the website. From assignment also, if you have any doubt, or if you want to discuss some question from the assignment, if you want any critical question or any question that need a thought, that type of question, you can ask, you can just send me that question, and I will discuss that in the next class. I'll also see,
Okay.
I'll also look for the question from the assignment. I will download it, and from there, if I find any interesting question, then I will also do it. Let's see. Next class, not next class, after that. After that, I will discuss. Okay.
Okay. Some question I find that the answer may be wrong in that.
That you said to me. Sometimes this answer, that mistakes are there. That's okay, but the concept should be correct. Answer sometimes that can't be matched, because
No, my answer is correct, but the given answer is wrong.
that's why I'm saying, because they have put the answer in. It is like, uh, I don't know. This, I think this is software based, so they have just put it the answer. So If that is wrong, then you can't do it now. It's not your fault, but you will not get the marks eventually. But I don't know how to deal with this. That is not important.
Yes.
Important is your answer should not be wrong. That's the important part.
Yes.
Okay. Okay, you can send me those questions as well. I will look at it. Okay.
Okay. Thank you.
Okay. Again, we will meet in the next week, Sunday at 4 p.m. Okay. Thank you for joining.